Good day. Welcome to my channel. This is Erwin Angelo V. Baduria, your math teacher. For this video, we will be tackling the computation of different rates. So at the end of this video lesson, you should be able to compute the nominal rate, effective rate, and equivalent rate of compound interest. Let's review the three different terminologies of this discussion. Number one is the nominal rate, denoted by I subscript n. This is the annual rate of interest, which is to be divided by the number of conversion units. This is how we define I subscript n from our previous discussion. Now the second one is the effective rate, denoted by I subscript e. Refers to an annual rate which will give the same amount of compound interest when converted from its original nominal rate. So from here, we will be using the nominal rate in order to convert it into an effective rate. An effective rate is an annual rate. Since the nominal rate it is an annual rate to be divided by the number of conversions, we can convert it into an effective rate, which is an annual rate of interest. The third one is the equivalent rates rather, denoted by I subscript m. This is two nominal rates with different conversion periods. Both rates will give you or will earn the same amount of interest for a common principal amount in the same term. The formula we will be using with this discussion is for the first one, the nominal rate, that is I subscript n, equal to the product of n and this bracket, nth root of f over p minus 1. Take note, 1 is outside the radical sign. For the effective rate, denoted by I subscript e, we will be using, it is equal to 1 plus I subscript n over n raised to n minus 1. Take note that it is an annual rate. And for the equivalent rate, we will be having I subscript m, which is equal to the product of m and this bracket. We have the mth root of 1 plus I subscript n over n raised to n minus 1, and 1 is outside the radical sign. Our example number 1, an amount of 1,000 pesos becomes 1,608 and 44 hundredths after 4 years, compounded by monthly. For letter A, we have to find the nominal rate of interest. So the nominal rate of interest is denoted by I subscript n. Our formula is I subscript n equal to n times the nth root of f over p minus 1. And minus 1 is outside the radical sign. Let's identify first the given values. We have the principal amount is 1,000 with a future value of 1,608.44. Within 4 years, the term is 4. And n is bi-monthly, that is twice in a month, and we have 12 months, so we have 24. So we have to find for the value of I subscript n. Substituting the values, we have I subscript n, which is 24, equal to 24 times 24 times 4 as the index of the radical, and our f is equal to 1,608.44 over 1,000. That's over p minus 1. So let's solve the index and the radical. So the index becomes 96th root. That's 24 times 4. 96th root of 1.60844 and minus 1 outside the radical sign. So what is the 96th root of the given decimal number of 1.60844? The answer is 1.00496295 and minus 1. And we have to subtract 1 from here. That is 24 times 0.00496295. Multiplying these two numbers, our nominal rate of interest bi-monthly is equal to 0.119108, or also known as 11.91% bi-monthly. Now for letter B, we are looking for the effective rate. The formula for the effective rate is I subscript E equal to 1 plus I subscript N over N raised to N minus 1. And then we have to substitute the values that we have. Our I subscript N as computed is 11.91 or 0.1191 to be divided by, that is bi-monthly, 24 raised to 24 minus 1. That will become 1 plus 0.1191 divided by 4 is equal to 0.00492625 raised to 24 minus 1. Adding the numbers inside the quantity, we have 1.00492625 raised to 24 minus 1. And then, we have to take the 24th power of the given number inside the quantity. The 24th power is 1.12615081. Then we subtract it by 1. The answer is 0.1262 in 6151 in 6 decimal places. So in other words, we have 12.6151% annually. So get 6 decimal places for the effective rate. Now let's have the equivalent rate. We are looking for a rate compounded quarterly from our nominal rate. Our nominal rate is 11.91% bi-monthly. The question here is that what is the rate of 11.91% compounded monthly if it's going to be converted into quarterly? So we have I subscript M is equal to M times the mth root of 1 plus I subscript N over N raised to N minus 1 outside the radical, close bracket. So we have to substitute I subscript 4 because that is M. We're looking for quarterly. That is M is equal to 4. Therefore, we have I subscript 4 is equal to 4 times 4th root of 1 plus our I subscript N is 0.1191 over 24 raised to 24 minus 1. Now, we already have an answer for this quantity raised to the power of 24. As provided in our solution B, now in the effective rate, this is the answer. Okay, that's raised to 24. So we have 4 times the bracket of the 4th root of 1.12615081, then minus 1. The question is, what is the 4th root of the given decimal number or the radicand? So we have 4 times the 4th root of the radicand is equal to 1.03014685 minus 1. We have to subtract 1 from the number. So we have 0.03014685. Multiplying these two numbers, it gives us in 4 decimal places 0.1206 or 12.06% quarterly, compounded quarterly. Okay? Now, our 11.91%, 12.61%, 11.91% bi-monthly, 12.6151% annually, and 12.06% quarterly will give the same amount of interest for these 3 rates if our principal is 1,000 within a term of 4 years. Our item number 2, 200,000 pesos. 200,000 pesos was deposited for a period of 4 years and 6 months and bears an interest of 85,649.25. For question letter A, what is the nominal rate of interest if it is compounded quarterly? So let's identify first the values of the variables that we have. The principal amount is 200,000 pesos. The term is 4 years and 6 months. That is equal to 4.5 years. And an interest of 85,000 pesos, 85,649.25 pesos. Now we have the future value now as adding the principal and the interest. It will give us 285,649.25. Now let's proceed in determining the nominal rate of interest compounded quarterly. So we are looking for I subscript 4. Let's use the formula. We have n times the nth root of f over p minus 1. So our n is equal to 4. So we have 4 times 4 of 4.5 as the index of the radical, and the radical is 285,649.25 over 200,000 minus 1. Solving the index and the quotient of the radicand, we have 4 times, that's 18. 18 came from 4 times 4.5. So we have the 18th root of 1.1.4282,476 minus 1. Now, what is the 18th root of the given radicand, of the radicand that we have? The 18th root of the radicand is 1.02 to be subtracted by 1. And then we have I subscript 4 is equal to 4 times 0.02. Therefore, our rate, nominal rate, quarterly is 0.08 or 8% compounded quarterly. Okay, now let's have letter B. So this is letter A. Now let's have letter B. For the letter B, we are looking for the actual rate of interest. Actual rate is the same as the effective rate. So the formula for the effective rate is I subscript E. That's 1 plus I subscript N over N raised to N minus 1. And then we substitute the values. We have 1 plus the computed nominal rate is 0.08 or 8%. So we have 0.08 over 4. That's quarterly. Raised to 4 minus 1. So we have I subscript E is equal to 1 plus 0.08 divided by 4, 0.02 raised to 4 minus 1. That's I subscript E. Adding the numbers inside the quantity, we have 1.02 raised to 4 minus 1. Now the fourth power of 1.02 is, the fourth power is 1.0824, 3216 minus 1. We subtract 1. We have 0.08243216. In 6 decimal places, we have 0.082432. In percentage form, we have 8.2432% annually. Now let's have letter C. For letter C, we are looking for the equivalent rate of our nominal rate into semi-quarterly. Okay, so we have M is equal semi-quarterly, semi is 2 and quarterly is 4, therefore M is equal to 8. Okay, so we are looking for 11 equivalent of 8% quarterly into X% semi-quarterly. So what is that percent? So we have to use the formula I subscript M is equal to M times the bracket of the nth root of 1 plus I subscript N over N raised to N minus 1 outside the radical. I subscript 8 now is equal to 8 times the 8th root of 1 plus 0.08 over, this is quarterly 4 raised to 4 minus 1. Now we already have an answer for the radicand that we have now. We are going to find for this number, and we have already solved this from our previous item. It is equal to 1.08243216 minus 1. So we have to get the 8th root of this new radicand. So I subscript 8 is equal to 8 times the 8th root of the given decimal number or the radicand. The answer is 1.00995049. To be subtracted by 1, we have I subscript 8 is 8 times 0.00995049. We have to get the product. The product is equal to, multiplying it by 8, we have 4 decimal places, 0.0796 or 7.96% semi-quarterly. Now, our 8% quarterly, 8.2432% annually, and 7.96% semi-quarterly will give the same amount of interest if we will be using our principal as equal to 200,000 pesos and a period of 4 years and 6 months or 4.5 years. They are all equal in terms of the amount of interest, though the values of the rates are different. For your practice, answer the 2 items provided on the screen and comment down your answers. For our real life lesson, rate yourself with the best that you can be. You should be the first person to appreciate who you are. So, be yourself and be confident to show to people your best. With that, see you in our next video lesson.